Bismillahirrahmanirrahim. So the thing here that with the programming, many people start to rush to write code when they hear there is a problem and then try to solve it with a code. But most of the time, when people rush to make the code, then a lot of problems happen. Actually, you make a very fast solution that need a lot of maintenance after that. I understand that sometimes you are forced to do that in some of the Malaysian companies. I have seen that in many cases, especially if you're working as the Chinese, they don't want you to think too much. They want you to start working immediately. So I understand that. But again, if you work with an international company, then this is a common practice that they have. You need to think first. You need to come up with a design, and then after the design, then you start working on. So I will give you an example how this actually applies. So let me try to okay. So I believe you can see my screen, right?
Yeah.
Okay, good. So this is a common example that is given and taught to children who are even less than 7 or 8 years old in UK and US. So if I ask you to sum the numbers from 1 until 200, which means I want you to tell me 1 plus 2 plus 3 until 200, how is equal how much in less than 30 seconds? What do you think? Is that possible?
Not possible.
Not possible, right?
Unless we got some from the like arithmetic.
Muzaffar, you're trying something, right?
Yeah.
Okay, good. So, Muzaffar, I believe you let me start to help you then. Muzaffar, are you still there?
Yeah, I'm still.
Okay. So, Muzaffar, let me try to help you because actually the trick is supposed to take only less than 30 seconds.
Yeah.
And if I tell you a count from 1 to 400, also it will take you a much longer time. If you don't know the trick, actually, it's not a trick, but it is a way to show you that we are able to analyze bigger problems into smaller one if we start to think first before we start to do. So if you rush to the calculator and try to calculate from 1 until 200, then you're taking the hard road and the longer one. But here, the point here is to learn how to analyze. So again, if I divide this 200, the number of 200, into two tables. So one table have 100 number, and another table got the remaining 100. Okay, and then we think 1 plus 200 equal how much?
100, 1 plus 200, 201.
Okay, and then we say 2 plus 199 equal how much?
201.
Okay, so what about 3 plus 198?
201.
Do you see anything common here? And what about
Yeah,
if we
yeah.
say 100 plus 101? How much?
201.
So it means that we managed to divide this 200 into two tables of 100s. And if we start to add every pair of them, we are able to get 201 as a common, right? So if I say 100 numbers multiplied by 201, which is the addition of every pair of the numbers, then I'm able to quickly reach up a solution for counting from 1 until 200. I think, if I'm not mistaken, it will become 20,100, something like that. Okay, the result itself is not the one that should worry us, but the method of reaching the solution is the thing that we should think about. So are we able to apply the same concept if we want to add numbers from 1 to 400? Actually, yes. So if we start to follow the same way, we are able to also divide the numbers into two tables like that.
Okay.
Okay. So allow me here to yeah. Okay. So we say 1, and you say plus, and 400 here. Okay. So we also add them, and they are giving the result 401. So if we put here 399, also it will give me 401. But of course, when I divide that 400 into two tables, the content of every table will not be 100, but it will be 200 numbers. So it means here, if I want to continue adding, I will add here until here reach 200. And here it will be, I believe, 201. And if we add both of them also, we will end up with 401. So if we want to make a multiplication like that to reach the number, what do you think? How much? So of course, this is a number, 200. I multiplied by what?
By 400.
See here? Yes, perfect,
Yeah.
perfect, perfect. So whatever the result, I just wanted to show you that you are able to, yeah, I mean, it doesn't matter the result. What matters to us that we are able to reach this kind of equation in the first place. So if I tell you now, count from 1 until 600, so somehow you are able to come up with a pattern. The pattern here actually is the key thing in software programming, finding a pattern in the information in front of you. So I want you to look. When we wanted to sum up from 1 to 400, we divided each table to reach. So I do some operation on 400 to reach that each table should be containing 200. What did I do? If what you need to do on 400 to reach the number 200, you divide it by what?
2.
Perfect. And here also you've done the same, right?
Yeah.
So it means that there is a pattern somehow. So if we want to talk about equations, we can tell if we have x, we divide it by 2 to reach the number of tables. So if we divide it by 2, it means we managed to reach the first number here in the equation without need to create this kind of table every time. Okay, so and then you have a multiplication here. So you put something like that here. How we reach this number without putting the tables like that? So look at the difference between this 400 and 401 and 200 and 201. Do you see any pattern here?
Yeah.
So it's saying that if we want to add to 400, it means that I'm adding 1 to reach 401, right? And also the same here, 200 plus 1 equal 201, right? So if I want to make an equation, I would say x plus 1. And this is the y, the equation. So do you know why I did x plus 1? Is that part clear for you? Is that equation part?
Yeah.
Okay. It's a pure mathematical thing. It is not always, I'm telling you, it takes some programmers years in real programming, in real projects, to be able to reach a common information and common pattern in the information and create some kind of equation like that. Okay. And not all the softwares that you write you need to reach up equation, but of course if you start learning that from the beginning and you start to analyze the information and look for common patterns, actually that help you. Okay. Okay, perfect. So let me go back to the programming and let us start something here. So just need to open okay, I think you started to see my screen, right?
Yeah, I can see.
Okay, so Muzaffar, anything in the programming, we need to take it a little bit by little bit. So most of the time when we want to do some operations on using the Python code, we need to take some parts of the memory and tell the computer, please save that information in the memory for us. So I would say we start simple. We say, okay, hello, Muzaffar. Okay, so I will run that program now first before. So you can see when I start running that code, it actually printed what I asked it to do. And the computer, Muzaffar, inside it is quite dumb. It takes its power from the programmer and it will not discover problems for you. You have to discover the programming problems on your own. The computer is just something that you give it instructions and detailed instructions, and it will do the instructions for you. Here, the computer only understand that when you are giving it the command print with a bracket, and then you put a quotation like that, and then you put whatever inside here, and then you end it up with a quotation again and a bracket, it will understand that this is a text that need to be printed into the screen. So, okay, what if we, Muzaffar, removed one of the brackets here? Is it the computer is smart enough to detect that a bracket is missing, or even can run without the bracket? No, it will not run. It will tell me that it detected an open bracket like that. If you can see here, they're telling me syntax error. So, okay, syntax error means that just simply is telling me that, okay, I noticed that you already put a bracket in front, but you didn't close it. So it means that the pattern that it is programmed inside the computer, he cannot find the same pattern. His pattern is to see print with open bracket and close bracket. You removed one of them, he will stop. He's dumb. He's totally dumb. He cannot recognize things if you don't put it in the way he is used to it. Is that clear to you, Muzaffar?
Yeah, it's clear.
Okay. So the same goes, Muzaffar, if I try to remove this double quotation. Also, it will not understand. Okay, Muzaffar?
Okay.
So, okay, good. I will try to do some things here. And so, Muzaffar, actually, I am moving slightly faster than other students, but I am just putting into account that you are a graduated person and you are professional already. So I don't want to move.
I can follow you. I can
Perfect.
follow you just now. Yeah.
Okay, perfect. So Muzaffar, I am trying to put something like that on the screen. Okay, so that line, Muzaffar, I am telling the computer there is something called variable, and that variable is called x, and I am giving that variable a value of 200. So what the computer is going to do when I give him this instruction? So it will go to the memory, Muzaffar, and the memory here, we call it RAM. I think if you built up a computer, then you should be aware of what the RAM is, right?
Yeah.
Okay. Later also I can share you more details. So Muzaffar, we have to close every 30 minutes. This is our the session recording, and then we have to open again using the same link. Okay?
Oh, okay.